In this example, we're going to determine the domain for this function. We have f of x equals the square root of x minus 2, and then this plus 7. If you'd like to go ahead and give this a try real quick, pause the video and do so, and then come on back and we'll work it together. So the problem that we have with domain when it comes to radical functions is that we just cannot have a negative number inside as a radicand whenever our root or our index is even. So we're doing a square root, so that's even obviously. So we cannot have the square root of a negative number because that comes out to be, well, imaginary and thus cannot be graphed on the real number line. So this x minus 2 that we have inside here needs to be greater than or equal to 0. So we just have to have it non-negative. Now the plus 7 here on the end is just going to be a vertical translation. It just moves the graph up or down and ultimately will have no bearing on its domain. Okay, so let's go ahead and add 2 to both sides to solve this inequality, and we'll see of course that x is greater than or equal to 2. So this is its domain, and we can write this a couple of different ways. So let's do it in set builder notation first. So we'll say the domain is, and we have the set, and you can say all x's, and you can put this real number here also if you like. This is kind of optional right there. So x is an element of the real numbers such that x is greater than or equal to 2. All right, so there's one way. Maybe a little better way, a more practical interval notation. With interval notation, we're just going to have a starting and an ending point. And so we're starting at 2, and the 2 is included, so we'll use a bracket. And we're just going everything larger than 2, so there's no stopping point, so we're just going up to infinity. And infinities always get a parentheses. So here then is the domain for this function. And here it's written in set builder notation, and here it's written in interval notation.